Can you hear me?
Yes, sir.
I'll continue. Okay, no, look, let's go for bulk modulus concept. Delta P by delta V by V. How you define the bulk modulus? The normal pressure by fractional change in volume, that one. So therefore this delta P, I can write it as minus B into delta V by Vi. Delta P is equal to delta V is what? Delta Y into S. Vi initial volume, delta X into S. So this will become minus B delta Y by delta X. This further, delta X will be very small. So this will become dy by dx. This is something very, very, very important. Now we know what is y is equal to. We are defined. Let me differentiate this dy by dx. So this will become minus ak sine kx minus omega t. Let me substitute that. So this will become delta p equal to minus ak sine kx minus omega t. So this better, let me write like a wave function it is. So this will become maximum pressure amplitude. I do have, and this is y of xt, or you can write it already we know, no? So this is like a y of xt, it is the wave equation. Okay, now you have to ask question, sir, what are this? I'll call this a displacement wave, and I'll call this as a pressure wave. Let me proceed further. Let me proceed further. So even density also varies, no? So how to bring the effect of density also? Even the density of the layer also is varying. So can I bring the density of the layer also? So I'll do one thing. We know density is equal to mass by volume. I'll differentiate this. I'll differentiate. So d rho will, okay, the volume equal to let me write like this: volume equal to mass by density. I'll differentiate this. dv equal to minus m d rho by rho square. So in that, m by rho d rho by rho. M by rho, what you can write it as v. So what is dv by v equal to minus d rho by rho. So therefore the bulk modulus, how you define dp is equal to dv by v. So in place of that, can I also write d rho by rho? So what is the maximum difference? So this will become d rho by rho is equal to and d rho. I'm interested in d rho. So d rho will be minus b rho dp. Okay, no. It will be like this, no? Rho dp by v. So what is dp? dp or delta p? Delta p is what we have the equation, no? So there minus bak sine kx minus omega t. One b get cancelled, so I'll end up with rho ak sine kx minus omega t. This will become d rho m. This is a density variation or density wave. No, very, very, very important. Almost, I think, the most troublesome part got over. Just only thing is, once again, we will summarize so that you get the exact picture. Oh yeah, this is what I'm studying. This is what I understood. It'll be very simple. I'll interpret all this mathematically. Okay, why I'm bringing so many things? So I'm saying pressure wave. You see that displacement wave. Then I'm saying pressure wave. Then I'm calling density wave. What is all this? I think everything. Let me bring it one place, one page. There's only graphical. There's a mathematical. A student has to. Let me take only this part. Yeah. Let me move this part. Why it is not? No, okay. Everything. So now you can ask questions. So like, what is this? You brought the three waves, but actually it's sound wave. But you're not talking about sound wave. You're talking about displacement wave, pressure wave, sound wave, density wave. But where is the sound wave, sir? Your topic name is something sound wave, and you are talking about the displacement wave, pressure wave, density wave. Let's go back to the first diagram. What is the first diagram? I will. There's the first diagram, no? So this we will. Oh, it is playing with me. How it is moving? It is not getting copied. Okay, I'm unable to paste copy it. Let me go back to the first diagram. If that diagram were there here, it would have been nice. Okay, that one. Let's see. I'll try once because only will take this. Yeah, I'm successful. Okay, now let's get into the total page I described. This is the concept. You need not to read any book again and again. The same story. Immediately you can start doing numerical. Your teacher really has put a lot of effort to give that basic concept. Okay, now when the person, when this person says I, and this person will is going to hear, no? So this is what we say, that there's a person two. Person one will speak, and the person two is going to hear. He will say that uh, speaking, and he will hear it. He will he will hear it. Are you able to see that one? So he says I. So when he starts speaking, what will happen to this layer? The pressure, density, and the layers in a chamber, they will change their position. No? The pressure will vary because I'm showing no P1, P2, P1, P2. The pressure is varying. What happened? Density, then density of medium also varying. And what happened to the layers in a chamber? They will vibrate. They'll execute SHM about their respective mean position. Sir, how to express that their motion? The Newton said that's take help of this formula. What Newton is telling, just take help of this formula. That the layers will execute SHM about their mean position. Little bit I'll move down. Okay, fine. This is the thing what is telling them, that the layers will execute SHM about their respective mean position. Then, sir, pressure is varying. How to predict the pressure? It's telling that now, sir, you wrote P1, but here you're writing delta P. Pressure also, what happened at all point will not be pressure P1, because again, the different layers. So the chamber what we constructed, no? Oh, I have to bring chamber also. Yeah. No. For your understanding purpose, what I just made that I made that pressure P1, but in fact, what this equation tells, what is the displacement of all layers will be same? No, the different layer, they'll have different displacement. Similarly, inside the chamber, the different layers, they'll have different pressure. On what basis you are saying? I'm taking help of this one. Put T equal to 0. A layer at X will not have any pressure change. What is the pressure there? Will be P naught. What about the next layer? Will have pressure more than P naught. Like that, inside the chamber also, the different layers will have different pressure. How much pressure will be? P naught plus delta P. Getting the idea? This is the thing which you have to here understand here. But sir, you said here pressure P1, just initially, no, it's a initial beginning stage. Compression, okay, inside here compression pressure is more than P naught, but inside the chamber also the different layers will have different pressure. I think slowly you have to come out of thermodynamics. In thermodynamics, what we said, inside a cylinder the pressure will be same everywhere. No, come out of that. Inside this particular chamber, the pressure at different points will be different here. So how to predict using this particular formula? So now I think we are in a better position. No? I am speaking. No, I'm at x equal to 0. I'm speaking here now. I'm going to generate a disturbance. Now, from me at a distance of 1 meter at t equal to say 2 seconds, what is the pressure that one? What is the excess pressure? What is the excess pressure? Given by this much. Then what is the absolute pressure? P naught plus delta P. So what is this? This is the excess pressure. Let me indicate red color. And what is this? This is the excess density. Okay, got the idea? This one. So what is the pressure at this point? P naught plus delta P. And what about density? Rho naught plus d rho. So like this, what happened? If a sound wave propagates, now we are in a better position. Say I'm speaking now. From my mouth is what origin? X equal to 0. From here, the disturbance is generated. From my mouth at a distance of x equal to say like at x equal to 15 centimeter, at t equal to say 3 seconds, what is the pressure? Yes, I'm able to predict. From my mouth, from my mouth, from my mouth at a distance of select it 15 centimeter at t equal 3 seconds, where the layer will be. Is it at mean position? Is it right extreme? Is it moving towards left? Or in the direction of wave? Is it at mean position, left extreme? Yes, I can predict here. So now we are in a better position, no? Like if I'm speaking, a layer from my mouth at a distance from my mouth, a given layer at a distance from my mouth at a given time, where it is, you can predict. In what direction it is moving, you can predict. What is the pressure there, you can predict. What is the density, you can predict. So shall I say that I expressed now the wave propagation? All of you, if you say yes, I'll proceed. If you say not understood, I'll repeat once again. Okay, got the idea? Meaning, what is x? X is what? The distance measured from the origin. Position of a given layer from the origin. So what is this equation will tell? Blue color one. What is this equation will tell? What is x? X is a position of a layer from the origin. What is y? The position of a given layer from its respective mean position at a given time. Getting this one? What about this? X is what? The position of a layer. So what is the excess pressure at a given point? Or what is the excess pressure at a given layer? And X is what I'm going to choose later. By using X, I can choose any point in a medium at a given time. There I can tell what is the pressure, where that particular medium is from its mean position, and what is the density at that particular point. So when a sound wave propagates, what all changes you notice? Means now I'm speaking in my room. Tell me what all will happen. The layers will be vibrating. Just imagine, no? Just imagine. The pressure will be varying, the density will be varying. This is what the Newton he was able to imagine long back when there is no mathematics much, there's no physics much. Just imagine. Now teacher is explaining, you are finding difficult on his own. He was interested, that's all. There's no other thing. So why he was able to think like this? He was interested. We do watch movies, no? We are interested, no? That's all. The science is same thing. So if you're interested, you'll understand and you'll explore. If you're not interested, all the stupid reasons will come. So that's why I'll never give any advice, especially in this particular science and technology. What to give advice? Nothing is there. You are interested, you'll get everything. You're not interested, you'll not get anything. Okay, fine. Anybody having doubt, please do clarify. I'll be really very happy if you say that we have understood, because I'm trying to explain the one which is without animation something. Okay, I'll go down. Okay, this is a little bit, sir. Still, sir, we are unable to imagine anything. Okay, you are saying something, mathematics, pressure wave, this wave, that one we didn't understood. Okay, now you